Hi, my name is Hassan. In this video I will explain to you an interesting, fascinating and significant idea in the field of physics. It is the EPR paradox. After the coming of quantum mechanics and suggesting different concepts from the known physics back then, some of the greatest physicists like Albert Einstein refused to accept quantum mechanics. So he collected all of his ideas to fight the quantum invasion. One of his fighting's paper was a famous one called EPR. It was published in 1935 by, of course, Einstein himself, together with two of his colleagues, Boris Wildowski and Nathan Rosen, which the first letters of their names form the paradox name. And it was against the Copenhagen interpretation that Niels Bohr came up with in 1927, and it was a new look to the reality. This paradox suggests the following words. Imagine a particle that decays into two smaller ones. If the original mother particle was stationary, the daughter particles must have equal and opposite linear and angular momentum, so that the sum is zero, as these of course are conserved. So the emerging particles must fly apart and spin in opposite directions. Each of them is on the side of the universe, which means a tremendous distance between them. Once emitted, if we were to measure the spin direction of one of the two particles, we would immediately also know that the other particle has the opposite spin. Even a significant time had elapsed and it was far away or even out of reach. If we want to explain this in the Copenhagen interpretation way, we would say that before any measurements, both particles existed in a superposition of possible states. The particles' wave function included information about them spinning in either direction. In other words, the particles had a mixture of all possible directions that can spin to. When we measure one of them, simply the wave function for both must collapse at the same time. In other words, the one that we've measured will take just one direction to spin. Einstein, Wildowski, and Rosen argued that this made no sense at all. How could you affect a particle instantaneously faster than the speed of light? Einstein had already shown that the speed of light was the universal speed limit. Nothing could travel faster than the speed of light, and that was the paradox. The paradox says that these two particles will affect each other instantaneously. How is that? And light is the faster object in the universe. So must quantum mechanics be wrong? Until the coming of our friend Niels Bohr and dropping his bomb. Bohr replied to this idea by supposing that the whole universe at the quantum levels is linked together. In other words, the two particles are super linked. What happened to one of them will affect the other one. It's like these two paintings, The Starry Night, that painted by the great Van Gogh, and on the left is a copy of it drawn by one of my friends. So it's like this. If I erased the tree on the copy that I got, instantaneously the tree on the real one will disappear. And I hope to do that because I'm very vicious. That happens in the quantum world, but not like the same way, of course. That's called entanglement. Both particles are entangled to each other. That beautiful term came from the dead and alive cat owner, Erwin Schrödinger, which he used it to describe this weird action at a distance. Eventually, the experiment showed that Einstein was wrong, and indeed such an act between the particles is really exist in our universe, and that due to the entanglement. The best part is that entanglement is true, and the quantum mechanics wins the fight again. This wonderful idea can help us to develop our technology, particularly in a technology called teleportation, which could transport us like from Baghdad to New York in a fraction of a second, but still not achieved yet. Thanks for watching and probably listening, I guess. Okay, bye.